Hello, how you doing? Have you seen how easy it is using Python to perform vector similarity searches using PostgreSQL? Well, if not, then watch along with me for the next few minutes and I will quickly get you up to speed. Okay, let's get started. So what is similarity search? Similarity search involves finding data points similar to a given query, crucial for applications like recommendation systems, RAG pipelines, and image retrieval. Vector databases manage high-dimensional vector data essential for efficient similarity search operations. In this video, I'll show you how to take PostgreSQL, an open-source relational database, and extend it to perform similarity searches, making it a versatile tool for AI applications. So to run this similarity search application on my local system, I've downloaded and installed an instance of PostgreSQL 17. You can download and install this database for free. I also have PGadmin, a separate application installed on my system. PGadmin, as the name implies, is an admin tool for PostgreSQL databases. It provides a UI for interacting with and managing PostgreSQL databases. PGadmin allows you to perform tasks such as querying databases, managing users and roles, monitoring server activity, and visualizing data. So in this example Python application I'm going to show you, it has two Python dependencies. The first is PSYCOPG2-binary. This enables your Python to connect to the PostgreSQL database. You'll want to execute pip install PSYCOPG2-binary in a terminal window to download this Python module. Next, you'll need to install the sentence transformers package. This is an embedding model we will use to create vectors from our test data. I'll explain in a few minutes why we need this package. You'll want to execute pip install sentence transformers to download this Python module. Now we have another last step we'll need to execute to enable our Postgres database instance to operate as a vector database. You will need to install a third-party extension called PGVector. Within a tool like PGadmin, you can execute this SQL expression, create extension if not exists vector in your database. Again, this extension is what gives your PostgreSQL database instance the custom vector data type and similarity search capabilities it needs for this example to run. So now, using PGadmin, I'll go ahead and create my database table, which will contain my vector data. Note, I'm using PGadmin, but you can use any SQL editor that is compatible with PostgreSQL 17. Here's the table I'm creating. The ID column uniquely identifies each row. The text column stores the descriptive data. The embedding column holds a vector data representation of that descriptive data. Notice that the embedding column has a dimension of 384. I will explain why I chose this value in a few minutes, but continuing for now. This table allows you to store and query vector data efficiently. Okay, so now we're ready to go through the Python code. First, I define my database connectivity parameters. You'll need to set your specific DB parameters based on your database setup. Next, I define a Python function that handles the actual similarity search. I pass in a database connection, the text to use in the similarity search query, and the top K parameter. The top K parameter defines a number of similar records to return. The first thing we do in this function is create an embedding using the query text. This query embedding is nothing more than a vector representation of the query text. This query embedding will be used in the similarity search. The similarity search will return the top K most similar records when compared to this query embedding. I have a video on similarity search algorithms. If you want to learn more about how this works under the hood, feel free to check this video out. But continuing for now. Now we go to the main part of the Python script. Inside of the main, I create a connection to the database. Next, I instantiate a sentence transformer object. This is my embedding model. I use this to create vector representations for chunks of text. Now, I define an array of text objects. In this example, I create some text objects describing various surf spots in California. Malibu, Rincon, Mavericks, along with other surf spots are included in these text chunks. Next, I use a sentence transformers embedding model to create vector representations for each chunk of text. This embedding model creates vectors with a dimensionality of 384. After creating an embedding, I insert a row into the database table, which includes a chunk of text as well as its vector representation. Quick note, since I knew that my embedding model created vectors with a dimension of 384, I also set the embeddings column in the database table to a dimension of 384. You want the embedding model vector dimensions to match the dimensions of the vector column in your database table. This is required to ensure accurate similarity searches. Now, with the vectors inserted into the PostgreSQL database, I can perform similarity searches on the database table. I define my query text, which is summertime right point break with long rides. Now, I call my similarity search function, passing in the database connection along with the query text. The similarity search function returns the most similar records, and the Python script prints them out. So now, I run the Python script, and here are the results. Here you can see the three most similar text objects. The text embeddings with the smallest similarity distance are closest to the query embedding and therefore most similar to the query text. So the text Malibu is a right-hand point break and gets good in the summer is the closest text to my original query. So now you've seen how easy it is with the right setup and tools to implement similarity search with PostgreSQL. Note, if you'd like to download this code example, the GitHub link is in the YouTube description. So in summary, using PostgreSQL as a vector database definitely makes sense for organizations already using it as a relational database. It enables more intelligent data retrieval, which is crucial for AI and LLM-driven applications. So let me know what you think of PostgreSQL as a vector database. Do you think you might use PostgreSQL as the vector database in any of your LLM-driven systems? Feel free to share your thoughts in the comments below. I want to hear what you think about this topic. Okay, thanks for watching. This video, along with all the other videos in this playlist, are listed in the YouTube description. I invite you to watch other videos on my channel. If you like the way I'm sharing this content, please consider subscribing. When you subscribe, this really helps my channel grow. One last thing. We all love technology, and we're all excited about all the innovation with the cloud and machine learning and AI. But don't forget to carve out some time to live in the real world. Go outside, go swimming, go hiking, go climbing, go surfing, but get out and move your body. And if you do, tell me in the comments. I want to hear about this as well. And with that, have a great day. Thank you.